So good afternoon, everyone. Thank you for joining us for this Mouser and Samtec webinar today. We'll get started in just a couple of minutes. So hello, everyone. Good afternoon, good morning, wherever you are. Thank you for joining us for this Mouser and Samtec webinar, enabling next generation intelligent process automation from sensors to servers. We're delighted to have Matthew Burns from Samtec joining us. Just a word about Mouser and Samtec before we get into the body of this. With more than 20,000 Samtec parts in stock available for quick delivery, Mouser is a global distributor of the newest semiconductors and electronic components from over 1,100 manufacturers. Today, as I say, we're delighted to have Matthew and Samtec with us. Please do feel free to ask any questions you may have on the presentation using the Q&A button that you'll see below, and we'll answer as many questions as we can at the end of the presentation. If you have any technical questions around audio or webinar functions, please use the chat function and someone from the Mouser team will do their best to help you. And without further ado, let me hand over to Matthew.
Hey, Mark, thanks for the kind introduction, and we're glad to be with Mouser today, as well as our listeners throughout EMEA and around the world. As Mark mentioned today, we're going to be talking about how Samtec and Mouser are enabling next generation intelligent process automation. And I really like the focus that we have from sensors to servers, so that helps us see that we're looking at the entire application when it comes to factory automation, process automation. Before we delve into the meat of our presentation, for those of you that may be new to Samtec, just want to give a brief overview of who we are. We've been in business since the mid-1970s. We are a global provider of high-performance interconnect. We are based in the U.S., in a town called New Albany, Indiana. It's in the Midwest of the U.S., right outside of Louisville, Kentucky. Even though we're based in the U.S., we do have global operations. We have a global agreement with Mouser, which we benefit from greatly, our relationship and synergies there. We do have over 40 locations around the world. In EMEA, we have our sales team, technical support, signal integrity support, and other back office supports through some of the regional offices we have across the continent as well. We continue to grow. We are a privately owned company. We consistently are ranked as one of the number one connector manufacturer by Bishop and Associates in many areas. That's mainly due to the feedback from our customers, so we appreciate that. As a smaller supplier in the interconnect space, we have historically grown faster than the industry growth rates. Looking over the last 10 years, we're roughly 2 to 1 industry growth rates. And one of the reasons we've been able to be so successful from a business perspective is the fact that we are not focused on any one customer or any one market. You can see there on the bottom right of the slide that we play in industrial, semiconductor, computer, datacom, medical, mil-aero, transportation, instrumentation, and consumer. So having diversified products that fit across a number of applications really has served us well. And we look forward to talking more about how we play within the industrial market with process automation. Some of the trends that we continue to monitor, at least from our perspective, are outlined on this slide. And as a caveat, right, there's, when talking about intelligent processing automation or factory automation or robotic process automation, we're looking at purely from Samtec's perspective. We work with a number of the leaders in this space. What are some of the marketing trends or influences that are driving their product architectures, their roadmaps? What are some of the commonalities we see across our customers, not only in EMEA, but around the world within this space? So, I think one of the things that all of us have learned in this crazy world that we've lived in over the last roughly 2 years with COVID is everything is becoming digitized. Whether it's our personal workflows, the fact that we're working remotely more often than not, or the fact that manufacturing and process automation within the factory is becoming digitized. It's just the world we live in. And we see that affecting intelligent processing automation. Again, because of global trends that we see with lack of work and supply chain issues, hyper automation. If it can be automated, companies are making the investments to do so. We continue to see multi-year trends around 5G and AI. Not only is that continuing to create new data, but also processing requirements. Where's that processing done? Is it all in the data center? Is it cloud, or can some of that be done at the node? We see evidence too of increasing workloads because of the data. Server class performance, server grade performance is needed not only in the data center, but also at the control center as well as on the factory floor. The need for more computing continues to grow unabated. We don't anticipate that to slow down. And we'll comment on how some of the things that Samtec's doing in the industry is affecting that. Industry 4.0, data pre-processing at the edge, open standards, right? For a number of applications, there's any number of suppliers, but how does everyone cooperate together? And then getting into the granularity from a tech standpoint, we continue to see increased performance. A good example of that, a number of embedded applications, especially in processing automation, are still using PCIe Gen 2, maybe Gen 3. We're starting to see interest across the industry at Gen 4 rates, especially as the compute engines have PCIe 4.0 natively within their systems. We're starting to see transitions to 5 in some areas as well. 10 gigabit, 100 gigabit Ethernet continue to be rolled out within the factory floor. That's the reality of the world that we live in because of more data. We're seeing the migration of USB 2 to 3 to 4 as well. And then manageability. It's not about managing and remotely monitoring everything via the cloud or the control center, but is there a way to self-heal or to manage things at the local level? Again, big trends that we're seeing affecting product architectures, roadmaps, and the like. Getting into more of a customer level or more of a design level, what are some of the design trends? When we talk about digitization, a big area that we see at the design level is sensor digitization, right? There's sensors of all types, whether it's a pressure sensor or a thermal sensor, fluid sensors. They have a variety of outputs. They could be a voltage, it could be a voltage-based sensor, it can be resistance, it could be current. A number of those sensors are analog. How do we get that data into the digital world? And it's not just a matter of attaching an ADC to it, but once the data has been digitized, how do you handle, where does it go, how do you standardize it? So we'll talk about some things that Samtec's been working on within the standards ecosystem and go from there. Increased computing kind of speaks for itself, more computing power at all locations across process automation. Power delivery. We're not talking about AC power. We're not talking about 600 volt DC. It's how do we get higher currents down to my PCB? What's really driving that? Increased performance. When you're moving from a 32-bit MCU to a server grade processor, you're going from a single watts to maybe dozens of watts or hundreds of watts of power to drive your chipset. How do I get that current, that high current from my power supply to my PCB? We'll talk about some things there, and obviously ever shrinking form factors. Sensor digitization is really interesting. I apologize for the crudity of the illustration of a manufacturing floor, but you get the idea. One of the things that obviously we're all aware of is that across a manufacturing setting or manufacturing line, there's sensors of all types. Whether that's machine vision, monitoring the quality of what's being manufactured, environmental, measuring temperature, humidity, event detection in case there's an intrusion, safety. There's any number of sensor types. And as a result of the plethora of sensor options there's challenges when designing intelligent process automation systems is how to standardize that data. Not only do we need to digitize that data and standardize it, but how do we get to the control panel? And then once it's done, once the data gets to the control panel, it's been digitized and standardized, how do we handle that at the control plane? Those are real world questions that many intelligent process automation manufacturing locations are trying to answer. I was at a trade show here in the US in person back in September and talked with an OEM manufacturer from one of the Silicon Valley heavyweights. And they were looking, this was a real-time problem. We had a very lengthy discussion about how he was challenged with digitizing all the sensors in his legacy location. So it was kind of real-time validation that these solutions are necessary. And really what that drives us to is what plug-and-play nodes are available within the industry, and is there a way to standardize that process? Well, one of the things that PICMIG, who's one of the leading embedded standard bodies, has worked on is coming up with a specification that just does that. Not only do we help out the sensor manufacturers in terms of providing a standard method to capture the data digitally with the control software, but also how do we standardize that at the MCU level once that data has been digitized? Obviously, we want to have some sort of firmware specification, looking at network architectures and data specification, and then how to handle that at the application level. So PICMIG has went through a number of processes or a number of efforts over the last several years around IoT connectivity, which ties into intelligent process automation from a manufacturing standpoint. And the specification that they've released, which Samtec and others have been a part of helping to push forward, is what we call microsam, or micro sensor adapter module. It's fundamentally an IoT architecture for distributed architectures for plug-and-play sensor adaptation. There's a small postage stamp PCB which enables interfacing to sensors of all types, with again voltage-based outputs, current-based outputs, resistance site outputs, et cetera, et cetera. The compact nature of the module allows for it to be targeted at industry standard MCUs, typically 8-bit, maybe some 32-bit, 16-bit and 32-bit solutions as well for digitizing sensor nodes, taking advantage of the scales of the IoT. But at the same time, these sensor nodes, this microsam, offer a parallel computing path where other PICMIG standards can also provide control. Think about the microsam at the sensor node, think about COM/Express or compact PCI at the control plane, and then compact HPC, or excuse me, COM/HPC within the control the control center itself. Some of the benefits of this new microsam technology is that it simplifies smart sensor design for sensor vendors who want to take advantage of it. Controller suppliers have a standard interface or standard solution for interfacing to sensors that want to become smart. And then it's really intended to accelerate smart sensor uptake technology through open specifications and interoperability within the ecosystem of those that adopt it. Here's an illustration of what the MicroSAM actually looks like. You'll see that it has three interfaces on it. One is for power, one is for interfacing to the sensor, and then one of the interfaces is to tying into the control panel. Key technical features, all the design requirements that you'd want to put around an MCU-based design have been captured within this standards-based approach. And all the design parameters, the connectors from Samtec, obviously, are available through PICMIG. And we're real excited. Samtec's real excited, and by extension, PICMIG is real excited to see the adoption of MicroSAM, especially as more of the application layer, the standardization are released as we move into 22. From Samtec's perspective, you can see that the connectors that we had on the PCB leverage our 1 millimeter micromake discrete wire systems. Just to talk briefly about these products, they come in a variety of configurations: cable to board, cable to panel. We support a number of variations, whether it's vertical or right angle. We support single and double row, anywhere from 2 to 20 pins per row. Because of the pin-to-pin spacing, these are very small and compact. Think about, if you go back to the MicroSAM, 32 millimeter by 32 millimeter, but there were still 3 connectors on the PCB. And then there's some regularization features that are available as well. We do have a number of our micromate product solutions available at stock via Mouser, and we'll show you at the end of the presentation how you can get more information on these and all other products. So MicroSAM shows about how to digitize sensors, but once that sensor has been, once the sensor data has been digitized, how do we handle processing all that data? Another standard that Samtec has worked on through PICMIG is COM-HPC, which offers server-grade performance at the edge. Many of you, no doubt, are familiar with COM-Express, and COM-HPC is really the evolution of COM-Express into the modern age of server-grade performance. So COM-HPC stands for Computer on Module for high-performance computing. It's an open standard focused on HPC for embedded applications. COM-HPC does provide 2 module types, both server and client. Samtec's contribution, obviously, is one of Samtec's contributions is the interconnect between the module and the carrier. There's two new connector types that are used to support the high performance and needed for next generation compute requirements. One of the advantages of COM-HPC over COM-Express is that because of the design hooks for increased power, increased size, it's not limited to x86 processors. So, there's in a number of applications, especially in intelligent process automation, there are reasons to leverage the inherent benefits of FPGAs or system on chips, or sometimes the acceleration capabilities of GPUs. So COM-Express enables adaptation of those compute engine technologies. COM-HPC is not a replacement for COM-Express, but it does allow for higher end CPUs, increased memory, and faster I/O. Just a brief snapshot of COM-HPC versus COM-Express. You can see on the right-hand side the scaled sizes of COM-HPC modules versus COM-Express. There's 5 different sizes, which provide scalability and flexibility. If you're an OEM that's designing a COM-HPC carrier card to fit your specific application, if you put all the bells and whistles and all the design hooks in it, as the ecosystem of COM-HPC carrier cards continues to expand, theoretically, you should be able to have the same baseboard for a number of years. COM-HPC does offer increased performance in terms of connector bandwidth at the pin level, 32 gigabit per second versus 10. There's 800 pins versus 440 with the COM-Express. And as we go through the rest of the comparison, you'll see there's more memory from a DIMM and SODIMM standpoint, increased power budgets, which allow for using the latest server-grade CPUs, whether that's from Intel or AMD or other providers there as well. PCI support for this up to 5.0. That's probably a little bit bleeding edge for a number of applications, but it's just a matter of time before we see PCI 5 adopted from the chipset solutions, whether that's CPUs, GPUs, or FPGAs. And then, support for USB 4.0 and 100 gigabit Ethernet as well. Some may ask, well, what about power? I don't want to go into a ton of detail here because there's a lot of data on these charts, but I did want to assure the listeners that when it comes to COM-HPC, the team that worked on developing the standard really looked at roadmaps from the chipset vendors. What's the embedded roadmap from Intel? What's the embedded roadmap from AMD and some of the other providers there? So you can see that the power budgets for the client module, 250 watts, total allows support for an embedded CPU of roughly 65 watts. And then, moving up to the server module, we can support CPUs with up to 150 watts of power. And obviously increased power needed for the memory and the support circuitry as well. So a lot of work went into how COM-HPC was developed to support next generation compute engines to support the needs of COM-HPC in intelligent process automation. From Samtec's perspective, we worked with various PICMIC members on identifying the appropriate interconnect between the carrier card and the COM-HPC carrier and the COM-HPC server. Excuse me, the COM-HPC carrier and the COM-HPC modules. My apologies. Samtec's COM-HPC connectors offer high performance, flexible open pin field array. Any of the pins on there can support high speed data, either differentially or single-ended, as well as power. The connector can support PCIe 5 and 100 gigabit Ethernet as shown. It does leverage VGA technology, not only from a density standpoint and also standard reflow processes, but it also helps for some self-alignment and board-to-board mating within the solution as well. Some of the mechanicals on the connector, 0.635 millimeter pitch, a 2.2, a 2.4, and a 2.2 millimeter pitch between the rows of the connector. We'll talk about that in just a minute as to why that's important from an SI performance standpoint, and then various stack heights of 10 millimeter and 5 millimeter as well. The 5 millimeter is ideally suited for those applications that are thin in nature. The 10 millimeter allows components to be added to the top side of the carrier and the bottom side of the module for increased performance as well. Just for any of you that are signal integrity focused, this illustration shows the row-to-row spacing of the COM-HPC connectors and why it was chosen. The increased row-to-row spacing allows PCB designers to maintain a ground signal ground pin selection for the high-speed transceivers, whether that's PCI Express or Ethernet, which increases the performance of the signals through the connector and through the PCB. More ground vias reduces crosstalk, and it also eases differential routing. You can see from the blue traces, we're orienting those high-speed differential pairs on a north-south projection here, but you also see that you can route those on an east-west projection as well. So the connector and the pinout were chosen for increased flexibility when laying out the PCB. Now, someone may ask, okay, great, Samtec, these connectors work. You say they work at PCI 5 and 100 gigabit Ethernet, but how do I know that? Well, here's some signal integrity data that shows the performance of the connector and a signal channel from the module down to the carrier card for PCI 5 signals. The insertion loss on the left-hand side, you can see both the red and the green. It's at 16 gigahertz. 16 gigahertz is the Nyquist frequency for both PCI 5. You'll see that the loss across the channel is roughly 1 dB. So that's really good. And then if you look at return loss, the general rule of thumb is as long as you're above 10 dB at your frequency of interest, you're going to get good SI performance. So at 16 gigahertz on the return loss on the right-hand side, you'll see both for the 5 millimeter and the 10 millimeter solution, we have good SI performance across the COM HPC signal channels as well. So if you need more data on COM HP signal integrity, please reach out to Samtec, and we're more than happy to provide more information there as well. We talked earlier about how increased performance on the compute side requires more power. So what are some of the solutions that Samtec's working on there? You know, this is one of the design trends that we're seeing. A number of next-gen intelligent process automation applications are taking advantage of advanced compute architectures, whether that's through COM HPC, like we just talked about, or other solutions from a discrete standpoint. You know, if you're designing in a server-grade CPU that needs 150 watts of power, that's a lot more current that you have to get down to the compute engine module itself. In addition, as we talked about with COM HPC, there's more memory, there's more I/O, which means more power delivery at the PCB level. So how are we affecting that? With COM HPC and a number of applications, we're able to get the required current through the high-speed connector, but in a number of applications, that becomes either cost prohibitive or space prohibitive. So Samtec has developed our mPower ultra micro power converters. This is a very flexible power interconnect solution that can be designed for power only, or when we say two-piece system, that's a power connector with a high-speed connector right next to it. And you can see that using mPower, we can get up to 18 amps per a single blade in a very small form factor. mPower continues to expand. Not only do we have board-to-board interconnect, there's right angle versions, there's vertical versions. We're working on, we have cable-to-board versions that are available. The stack heights on mPower vary from 5 to 20 millimeters. There's also, while not illustrated on the slide, there's also some ruggedization features such as optional weld tabs, and then the cable version, there's latches and metal. So there's either plastic and or metal side latches as well. This is just an eye chart, but what this slide shows is that between the 5 to 20 millimeter stack heights of the board-to-board mPower, they complement the standard stack heights of Samtec's high-performance signal connectors. So again, mPower is really designed for those specific applications where high current at the PCB level is needed, but in a very small space. The current specifications, you can see, you know, depending upon what grade of the connector that you use, how we come up with the 18 amp specification. Obviously, the more blades that you have, or more pins that you have in the interconnect, there's a certain physical limitation that you're going to get to, especially as temperature rises and as current demand rises. But we can provide additional data there as well. We can also support creepage and clearance concerns, whether using the standard products or coming up with something custom by removing pins. So if you're interested in more detail there, just let us know. Just an example briefly of where mPower is used. This is a FPGA module from Samtec and Mauser partner, Reflex CES. You can see that on the bottom of this FPGA module, there's a number of Samtec high-speed interconnect that routes the high-speed differential signals from the FPGA through the connectors down to a carrier card. But this design also leverages an mPower connector here on the bottom left-hand side of the PCB to get the high current delivery for the main power bus on the design. So not only have we worked with Reflex CES, but we're working with a number of intelligent process automation application solutions like this that leverage the benefits of mPower. Lastly, just want to talk briefly about how we're seeing small form factors within a number of applications. You know, increased compute power, increased functionality, but systems aren't getting bigger. they're getting smaller. COM HPC is a good example of increased power within a small form factor, especially when it comes to embedded computing. And again, factories are not getting bigger. More and more OEMs within intelligent process automation are trying to cram as much functionality within a limited or within the same workspace. So what are some things that are being done to decrease size and increase density of systems? In intelligent process automation, from Samtec's observation, edge card connectors are still popular. So we're starting to see more and more adoption of smaller pitch edge card connectors that in turn are making the systems smaller. So a number of legacy solutions continue to use 1 millimeter edge card solutions, which Samtec has available through Mauser. Our MEC1 family comes in both right angle and edge mount solutions, and then we have a number of other applications around 1 millimeter, supporting up to 140 IO. We also have a number of smaller pitch edge card solutions, specifically at 0.635 millimeter and 0.8 millimeter. Our MEC8 DV, our MEC8 VP, which supports press tails for rugged application, are very popular in a number of intelligent process automation solutions. And then we also have even smaller edge card connectors with our MEC6, which is a 0.635 millimeter pitch. The nice advantage too of these solutions is that they still, while they may not support the highest speeds of data that we see in the system, there's still a number of applications at 25 gigabit that these connectors can pass. And then lastly, the smallest edge cards that Samtec makes is our 0.5 millimeter, so our MEC5 families. There's also, one of the concerns that we get from not only intelligent processing automation, but a number of industries when it comes to edge cards this small is tolerance stack up. How do I make sure that when I design my PCB to go into one of these connectors, I'm going to get the alignment that I need and the signal transition from the PCB to the card edge, to the gold fingers, et cetera, et cetera. So our MEC5 series, both our DV and RA, uses justification beams, which in essence helps to seat the PCB within the edge card connector to give design assurance that the signal transitions from the PCB to the connector are met. We can get up to 300 IO within our MEC5 family. You can see that they're PCIe 4.0 capable, mating with industry standard 1.6 millimeter thick PCBs. So when it comes to intelligent processing automation, briefly through our presentation today, you see that Samtec and Mauser offer a comprehensive portfolio of high-performance interconnect solutions, ideally suited for those type of applications. We've covered high-speed board-to-board. We've talked about card edge. We also have a comprehensive portfolio of cabled solutions and precision RF products available through Mauser that we didn't have time to delve into. Samtec also backs up our high-performance interconnect with a global team of technical experts, online design tools, and world-class customer service available around the world. For more information on the products that we focused on in this webinar, as well as the entire portfolio that we have available through Mauser, we encourage all the listeners to visit mauser.com/Samtec. And for technical support, you can contact us at sig@samtec.com. Marcus, we'll turn it back to you for, Mark, I apologize. Mark, we'll turn it back to you for any questions from the audience.
Thanks, Matt. Thanks for an excellent session, and I think a really good overview of the sort of, as the title described, really, sensors to servers. So really nicely done. Thank you. Yeah, so in terms of Q&A, then we've got a few questions. Let's see what you can make of these. So first off, I think going back to COM HPC, what are some of the popular applications that you're seeing from COM HPC?
Yeah, that's a really good one. From Samtec's observation and from what we're seeing from our partners within the comm HPC ecosystem market, it's really sky's the limit, right? Obviously, intelligent process automation, factory automation, process automation, a lot of industrial applications, robotics are very popular. We're also seeing expanding upon that. We're seeing interest with comm HPC and fog and edge computing applications. We're seeing interest in some 5G station, or especially as 5G gets rolled out in open RAN applications. We're seeing some interest in gaming, believe it or not, when it comes to. I was just in Nevada over the American holiday this past week, and we're running through the airport, and we're seeing these gaming machines, brand new state-of-the-art gaming machines. The same user experience that we like on our phones and our TVs at home. We're seeing in gaming applications. Whether that's in Las Vegas or other gaming resorts around the world. Sorry, got an aside there, just real time feedback. But yeah, comm HPC is really it's doing really well, and because of the high speed and the increased performance and the small form factor, it's a next generation embedded compute platform that's going to be around for a number of years.
And as you mentioned 5G, I think we're seeing the same thing, that 5G in industrial applications, particularly as you look to the rollout of Industry 4 across process control and automation. There's a big opportunity there, I think.
Yeah, couldn't agree
so
more.
A couple of others. One around the micro-SAM interface, because that's interesting how you can interface multiple sensors to that. So how does micro-SAM interface to multiple sensor types? Can you flesh that out a little bit?
Yeah, there's a lot more. We don't have time to go into the technical details here, Mark. But in working with PICMIG, really brings together scale. I don't think any one company is going to be able to promote a standard that the industry is going to adopt. But PICMIG, because it represents over 800 companies from around the world, and there's a lot of interest in that micro-SAM, was able to come together and standardize on a technical solution that through one interface, the sensor interface on that micro-SAM PCB we talked about, allows for interfacing to sensors that either output a voltage, sensors that output a current, sensors that may use resistance or capacitance, or even a PWM output. So having that one interface that was able to have all those inputs come in, and then standardizing the analog interface from those signals to the front end of the ADC. A typical, I think it's a 12-bit ADC that we assumed on the 8-bit micro that we used. All the recommendations on the analog circuitry, as well as the interconnect between the sensor and the ADCs, are captured within the specification. The PCB picture that we had in the presentation actually illustrates that in terms of the components that are in there as well. Block diagram information is obviously available in the standard available from PICMIG.
Excellent. One about power, because of course we touched on power a little bit, and we're seeing power requirements perhaps increasing. What about, because we're talking about industrial applications, are there any new rugged or power interconnect solutions that Samtec is working on?
Yeah, the short answer is yes. We're not. Let me put a caveat on that. Samtec's not trying to go and get into high power when we're talking 600 volt AC or 250 volt AC or other, or even the kV stuff that you see maybe coming into the factory floor. We're really focused on PCB interfaces or box to box. A good example of where we're continuing to expand power is the fact that we're working on panel to panel or cable to cable versions of mPower. We've been pleasantly surprised at the adoption of the mPower product line within the market space and across industries. We really targeted mPower as a board-to-board power delivery, again, complementing our high-speed connectors. But once it got out in the market, our customers started asking, well, hey, this is great, but I need to go from PCB to PCB. Can you help me do that? And others, okay, I can go from PCB to the panel, but I need something to go from panel to panel, box to box. So, we've got a good representation of mPower available through Mouser, especially in some of our new product releases that we've put through Miles around the globe. But we're working on more solutions to expand Empower, and your listeners will see that through Mauser later in 22.
Okay, excellent. Thanks, Matt. I think actually we're coming up to a point where we need to wrap things up now. So thanks again for the presentation, excellent overview, and for the Q&A. Thanks to everyone for joining, of course, and just a little bit of housekeeping now. Questions that we've gone through today and any others we receive will be answered in writing and be made available to all participants. Should you wish to watch the webinar again or share it with others, of course, which would be really good, it will be available on demand very soon. And finally, there is a short survey coming up. We'd be grateful if you could provide some feedback to help make our future webinars better. So thanks again, everyone. Thanks, Matt, and enjoy the rest of the day.
Thanks, Mark. You too. Have a great day.
Cheers. Bye-bye.